channel, and then possible booster 9 lift at Star Base. We'll switch it over to Science and Tech. Let's see what's good. Have I told you that I hate working on German cars? You've mentioned it. I mean, Sawyer, it's so ridiculously obvious that those cars were designed by somebody with CAD that has no idea what they're doing working on a car. Like, it's very clear with a lot of, like, Mercedes designs that the people that design the cars are not mechanics. And I think that shows. Broken flex plates look to be fairly common. Yeah, Hellfish, they are. That's a thing that they do after a while. And that flex plate came off of a Jeep from the junkyard. S had to replace the engine because somehow he broke a 4-liter inline 6. I don't know how he did that. I think he may have bought it from the previous owner with some rod knock. Yeah, but somehow, I mean, the motor had, like, God knows how many miles on it, you know. So that one, that 4-liter in there is actually from a TJ. It's from a TJ Wrangler, which is pretty cool, and it bolts up because Jeep. BMW's alright to work on till around 2006, then things get messy. So, yeah, he replaced that 4-liter. He did that by himself with his, well, not by himself. He had his dad helping him. Yeah, I have the facilities to take the Jeep apart and leave it apart for a couple of days, and that's how long it took us to do the flex plate because I didn't know what I was doing, so I had to be very careful. I didn't want to break anything. You know, taking the transmission out, etc., etc. Yeah, we did it right. We flushed the transmission too because I didn't want to pull the thing out from the bottom of the Jeep and spill transmission fluid everywhere. Didn't take the torque converter out. Torque converter stayed primed. So yeah, I mean his Jeep has other problems now, but that's what you get with old cars. You fix one thing, something else breaks. You just gotta go down the line. XJ, his Jeep, I think, is starting to get some wiring problems. I noticed that somebody did some really weird stuff in that thing. So, actually, I have a question. How familiar are you with the wire harness? Actually, now I figure I'd pick your brain, dude, if you're still here. How familiar are you with those things? I know it's in your name, so I'd assume it's pretty familiar. Steve Morris found what was causing the 890-degree temps in his converter. He had the pump passage block. You know it pretty well. Okay, dude. Oh, so somebody wired something in, and this is over by the battery on the left. So like if you're looking in the engine bay on the XJ, it's over on the left hand side. Here, let me show you real quick. Like, okay, let me see if I can find a good picture. So I need one with cruise control. Okay, so over here, you have a vacuum accumulator, right? And that's teed off of the intake manifold, right? So there's a boss right here for vacuum, and the cruise control is using vacuum, right? I don't think S is here. It's a 97. 97, right? Something weird is going on here. So it's not necessarily with the vacuum accumulator, but you have the vacuum accumulator, and then on a 97, the cruise control diaphragm is over here. And the cruise control diaphragm, here, hold on. Let me see if we can just go 97 Jeep Cherokee engine bay. All right, I found something very, very, very peculiar with the wiring here. So I'm just trying to find the right picture. Yeah, this one's good enough. So there's your, yeah, that's it. There's your vacuum. It's teeing off the vacuum accumulator here, and there's your diaphragm for cruise control. Basically, it's picking up on vacuum, and that diaphragm will basically is on a linkage that goes up here that tugs on the intake throttle body, right? And it'll hold it in position, cruise control. So it'll hold it with the throttle open, so you can basically just set it and forget it, right? And then when there's a solenoid in here that introduces vacuum to the diaphragm to get it to pull, right? So there's a wire harness that goes to this. Part of the wiring comes down under here. You can kind of see it. There's your vacuum line right there. See the vacuum line? It tees off and then it goes in there. And then you have your chassis ground, right? See that wire harness right there? That harness goes. So one of the wires goes to the horn, goes to the low horn that's down here, right? So there's horns on both sides, right? And then it splits and goes up here. Your engine bay looks exactly the same. Nice. So somebody, this was not factory. Somebody spliced off of this harness right here, and there was like 5 or 6 wires that went down around the battery tray and went down behind the light. And those wires basically led to a factory style plug that looked like, I kind of cross-checked it against Jeep harnesses. It looks like, the connector looks like the connector for fog lights. So somebody had foggers on this at some point, right? That's pretty foggers. But why the frick would you tee the fog lights off of the cruise control harness? And don't get me wrong, there is one wire that goes down there to the horn, but that one would seem to have been cut and spliced too. It was very strange. What about an EJ logo on our place? If you guys want to do that, go ahead. I'm not interested because they aren't very bright. So XJ, my question is this like something that people do? Is this like a known mod that you do to XJs to splice in a fog light harness if you don't have one? Or did somebody just say, I want fog lights, I need to find switch 12 ignition, and boom, there we go? Because, dude, yeah, there was like, to the cruise control harness, there's like 3 wires. There's 2 that go to the cruise control, because there's a relay in there, I think, and then 1 that goes down to the horn. There's another horn here. There's horns on both sides. And somebody spliced off of that and spliced in a fog light connector to that. I don't really understand what was going on there. It was a mess, though. Like, it was to the point where I wanted to take all that crap and just cut it out. I didn't have time to do it, but it was a nightmare. It's just 12 switched. Yeah, I mean, I don't have the Jeep in front of me, but if I had had more time, I would have. The other dude, somebody botched the wire harness in this Jeep. It's pretty embarrassing, whoever did it, right? So another thing that I noticed is that on the negative terminal of the Jeep, there's a red wire spliced off of the negative terminal. That red wire is bypassing the factory engine ground. So there's, inside of the harness right there, there's a black wire, and the black wire connects right to the engine block. Technically, it connects to the not the solenoid, it connects to a post on the engine block, right? And then the red wire, as far as I could tell, was just doing literally the same thing. So you had a double negative connection here on the Jeep. You had your chassis ground strap, right? And then you had 2 wires going to the engine block. One of them black, one of them red, off the negative post. I don't know what the heck someone was trying to do with that. I seriously don't know why someone would bridge that connection. It's very peculiar. But, yeah, S is having some... has some weird. There's some weird wiring gremlins in this thing, but yeah, with stuff like that, I just I'd have to go over the whole harness. We ran out of time. You had to go. That sounds like they had a grounding problem and added more grounds. Why would you? Yeah, but a grounding problem is the connection between the wire and the post, not. It's usually not the wire, and I mean it might be. In which case, they have a negative wire that's going through there that's frayed, and that could cause a ground. Oh, have them check out all the ground points. Yeah, for real. The ground straps break quite a bit, so it was probably a temp fix. Yeah. Okay. I didn't say they were smart. Yeah. So somebody had been mucking about in that thing and did some real backyard stuff. And don't get me wrong, I'm not hating on backyard stuff. If you can make it work, you can make it work, and that's the truth with cars. If it's stupid and it works, then it's not stupid, right? But yeah, it's still something a little strange. That's why the reason. That's why I'm asking. Unfortunately, I can't really help with a photo or being there in person. Also, I agree with XJ. Have them check all the grounding points. Ground straps break quite quickly. Yeah, I looked at the grounding straps from block to chassis, from engine to negative post, and from negative post to chassis. They're on their way out, but I tested it with a multimeter. You're getting it has the connection. It's there. Dude, I could spend a week with a multimeter in there messing with things, trying to get it fixed. But yeah, somebody went messing around with a wire harness, and then I don't know what the hell that thing's going on with splicing like 5 or 6 extra wires off of the cruise control solenoid. That's weird. I don't know why somebody would do that. I can't figure that out. Like the red wire on the negative post, I understand that might be a grounding issue. The wire might be frayed, so you bypass it. That makes perfect sense to me. But also, like, why would? That's very weird. Did they tow? I don't think the previous owner towed Racer. I'm not sure though. Bad idea. Sounds like something you'd done when you were 15, especially with a 12 gauge red wire. Like, what are you doing? Even 12 gauge for the negative ground on the battery, that's not a good idea. You need like 14, 16 gauge to do that. I mean, that's asking. That's asking for trouble. Yeah, somebody did go mucking about with this wire harness, so we gotta go figure it out. Reverse that, Hellfish. Yeah, 10 gauge wire. 10 gauge wire is what battery terminals are. Sorry, gauge is smaller number, bigger gauge, bigger thickness. I forgot. It's like shotguns. Yeah. Very weird. Very weird. The biggest problem Chief Bob. Yeah. Well, have him message me if he wants another set of eyes. Okay, actually, I will. Thank you very much. Yeah. Seems to be okay now. I mean, there's no problems from the engine and transmission because I had time to look over all that. I mean, it's a 4-liter Jeep engine. It's not going anywhere. Like, it's fine. I did the old mechanics trick of putting the screwdriver to the valve cover. There's no noise. There's no ticking, no knocking, no nothing. That motor's nice and healthy. It's really, really quiet. Like when you know how you can tell if a motor is healthy when you go to start the engine, guys, and you open up the hood and you don't hear the blah, 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 blah from the motor. If you don't hear the motor and all you hear is the belts moving and the fuel injector solenoids ticking off, then the motor's nice and healthy. We should find a dual overhead cam head to put on that 4-liter. I don't think there's anything off the shelf for that, Hellfish, but I mean, that'd be nice. I'd prefer to do it with the 4.9 Ford inline 6. That would be cool. Actually, you know what you know what, dude? The Ford, the 300 inline 6 doesn't even need dual overhead cams. You know what it needs? Crossflow heads. Like that guy that put the LS heads on it, I guarantee you that would make that motor very nice. It's the reverse flow heads that are Just too much turbulence. Too much turbulence. Taking the air, putting it in one side of the engine, and then having it go 180 out. That's, yeah, too much turbulence. At that point, just swap an 8 in. Yeah. Anyway, yeah, actually, sorry about the little detour, fellas. You know you were here. I figure I'd ask. It was very strange. Spliced off of the cruise control harness. Anyway, let's get back to 9. What's 90 doing? One of the worst issues I've ever had was with a wideband system from Innovate. It had the most temperamental ground I've ever seen. It popped 3 of those things before I said this is garbage. Interesting. So, I mean, people seem to be clear of the pad. We might be seeing a lift here soon. The pilot posts are down in the retracted position, which means that the booster is only being held in place with its hold downs. But then again, the pilots would be retracted either way. Here, let me check something. I'll see if we can get some info on what's going on here. Looks like they're waiting for the pins to come out. How about going for an electric powertrain with buffer batteries powered by one of these? An APU. I would like to do that. Aqualux, I think turbine electric is probably the most sustainable way to go. Turbine being used as an APU. The reason why is because a turbine doesn't need carbon-based fuel to work. I like turbines. Turbines are the GOAT. You can literally put anything that's flammable inside of them. You could put tequila in there. You can make it run off vodka. You make it run off potatoes. That's fine with me. I'd love to do that, dude. We'd have to find the right car. Actually, I know what car we should do that with. I know what car we should do a turbine electric with. That. It's a good idea. It's a good idea. That would be cool. Can you imagine jet engine noises coming from that thing? DeLorean's already doing that now? No, not turbine electric. No. Biggest problem with turbines is the maintenance, but then again, turbos have become fairly standard. Oh my gosh, why haven't we thought of this, right? Dude, that's... Oh.
Test at the launch pad. Please return to the beachhead. Repeat, you are inside the blast danger area for today's test. Please return to the beachhead.
You got 100K to buy one. Yeah, we can find one without an engine. Sawyer, what was your last? So now with our 48 volt system, the alternator is between the bell housing and the torque converter. We have to use 48 volt because a 12 volt alternator would be in the 50-60 pound, would be the 50-60 pounds. The integrated starter alternator are a pain to replace. Oh, integrated starter alternator? Dude, I mean, that's not a bad idea, but... Ugh. There was just an announcement on the PA that says that you're in the blast area for today's test. Please move. Here you go. Honeywell APU. I'm telling you, man. Turbine electric. It's a good idea. Turbine electric DeLorean. Because you could say, no, this sucker's electrical, but I need a jet engine to generate the 1.21 gigawatts of electricity I need. I don't think we're generating that much, but also, it's fun to say. Our cars draw about 150 amps. Sawyer. What the frick are you going to do with all that? 150 amp alternators? What is it, a semi-truck? You are in the blast area for today's tests. No, a fridge will not work. Nice truck. You guys can't see it. It's behind me. That's why we use 48 volts. What is... Sawyer, is it a hybrid? Is the car that you're working on hybrid, or are all Mercedes a 48 volt system? What the frick is 48 volts? Why would you operate at 48 volts? That's so strange. With a car, that's very, very peculiar. Why not just why not use an inverter? That, whatever. There's probably a good reason for it. There's probably a very well thought out and logical reason for them to use 48 volts in their system. I just do not know what that is. .48 volts at 150 amps. What the hell are you doing? That's a very weird combination. Tesla is moving to 48 volt. You need 4 times less copper wiring. Copper wiring diameter. Wait. Okay, Mason, explain. Talk nerd to me, baby. What do you mean? Why do you need 4 times less copper wiring diameter for a 48 volt system over a 12 volt system? I'm confused. Because more voltage, less amps. Rule that served me well my whole life. If you don't understand something, it's not stupid. You just don't know enough about it. Bingo. Tyrannolist, that's kind of my creed that I live by here. If I see something with this that I don't understand, or somebody's saying something to me in chat that I don't understand, I don't go, that's dumb. I go, I don't... It's like that for a reason. Why is it like that? I want to know. But I agree with you, man. I'm right there with you. Absolutely. Higher voltage is same wattage but less amperage. More voltage is less amps. But they have more amps, guys. Only Mercedes 48 volt system cars are hybrid or full electrics. Okay, I got you. No, the S-Class, GLS, and E-Class have about 150 control units. The 48 volt system only runs the starter, and then the 48 get converted to 12 via a DC to DC converter. Got it. Okay, yeah, it's for certain systems. All right, that's fair. Think of it like a high-speed shaft. Speed equals voltage, torque is amps, HP is watts. Yeah, Aqualex, you've told me that before. I mean, keep saying it, it'll eventually sink in. No, I'm not trying to be a dick, but I'm serious. It's why high voltage lines are high voltage. It's 150 amps at 12 volts. Interesting. The new S-Class, GLS, and E-Class have 150 control units. 48 volt system only runs the starter, and then the 48 gets converted to 12 via DC to DC system. Same reason electrical transmission lines are high voltage. Same power transmitted with less amps. Yep. Yeah. It's not the volts that'll get you. It's the amps that'll get you. Gotta be careful with that. 48 volt was abandoned in the U.S. car market years ago. Former Snap-on dealers sold many 48 volt test lights to customers. That was a waste. Interesting, Smutty. What American cars were using a 48 volt system? I would guess probably like Cadillac or something, but who knows? Volts hurt, amps kill. Yeah. Can we name that the album for our non-existent metal band? Yeah, they're coming out with their new album, Volts Hurt, Amps Kill. Or VHAK for short. The volts that jolt, the mills that kill. Yeah, there you go. None, but it was supposed to be a thing. Interesting. Isn't Mercedes partly American? I mean, they manufacture stuff here, Erudite, but yeah, no, it's Deutsch. Yes, the Tesla 48 volt system will only be for the low voltage components, but will increase efficiency and have less losses. The reason almost everyone has stayed away from 48 volt is due to less off-the-shelf components. Tesla is moving to almost all in-house electrical components. Interesting. I'll send you some reading material if you want, please. Hey Tars, good afternoon everybody. Oh, Starship plushies. Tars, good afternoon everyone. Question for any electricians in here. I have a small fan in my window and I just found out if I press on the plug of a power strip on the other side of the room in a completely different outlet, the fan cuts off. How exactly does that work? If I have a small fan in my window and just found out that if I press on the plug of a power strip on the other side of the room in a completely different outlet, the fan shuts off. How exactly does that work? The plugs, it seems like your plugs are in series. That's weird. I got 15,000 volts at 12 amps into my elbow. Wouldn't recommend. Yeah, Raiden, that sounds painful. I tell you what, I was doing a summer job. I was working a summer job one time doing demolition work. Literally, it was a good job. You literally just get to put a sledgehammer through walls for like 8 hours a day. It's tiring, but man, is it satisfying just putting your foot through a freaking door or something. Yeah, I was doing interior demolition, right? And I put, this was when I was like 15 or 16. I put a sledge through the wall, right? And this was, you know, I put it through the wall. I started clearing stuff out with my hand, right? And I put my hand into the wall. Bad idea. And I touched a 120 line. Yeah, that was a strange feeling. It didn't hurt, but it was just weird. Yeah, and then I was like, what the frick? And then I pulled the wire out and I touched it again because 15, right? And I was like, whoa, cool. Yeah, that was a strange one. It was just basically a regular plug, which I know what the voltage is. I don't know what the amps that those things carry. Yeah, it felt like your whole body was vibrating. Yes, pretty much. Mm-hmm. Yeah, you felt every muscle. It felt like a muscle jolt. Yeah, very weird. Series wiring is actually common in houses in the 60s and 70s. Yeah. Mm-hmm. Yeah, it was a little strange. When I turn my lamp off on my desk, one of my monitors turns off for a couple seconds. I always thought that was strange. Well, interesting. Europlugs are 220 at 15. Interesting. Yeah, you might want to check the outlets. Or have an electrician check the outlets. That probably shouldn't be happening. Oh yeah, Clayton, I was awake after that. And then the older guys that I was working with, because I was the youngest there, were like 25, 26. They were like, feel the jolt? And I'm like, yeah. And they're like, yeah, be careful. Those are live wires. I'm like, thanks for letting me know. Things pull power, they don't get push power. Yeah. Wonky wiring can do all kind of weird stuff when the load shifts. Bingo. Yeah, exactly. I mean, once I started kind of electricity and how like electrical engineering works made a lot more sense to me when somebody in chat described it to me like water flowing through a pipe. Like, you know, you have pressure and you have current, right? Like current with current, like water. They're not the same. Not the same. One's a liquid, the other one's electric. But yeah, that made electricity make a lot more sense. Why would you be demoing without turning the breaker off? I'm pretty sure somebody forgot, Creeper. This was like 20 years ago, dude. Yeah, Sumo, exactly. I've started using leftover OEM connectors for all my DC wiring needs when they're proper rating. Yep. Actually, Hellfish, wiring cars is fun, dude. I actually enjoy it. You know, I did it once with the truck, and for whatever reason, it just clicked in my head. Like, it's one of those things where you just kind of see it. Like, I do it once, and I understand what needs to be done, but, like, it's the same kind of itch that scratches, like, when you're building a computer, working on, like, cable management and stuff. Same exact thing, dude. Like, splicing the pins and the connectors and all that stuff. That's fun, dude. I actually enjoy that. It's tedious work, but I like tedious work because I'm weird. Just wait until you start using the OEM parts. It makes it so much nicer. Yeah, Hellfish, I think at some point, dude, I'll probably rewire the 59 with the Deutsch connectors like what we planned on doing. But for right now, the bullet connectors are fine. Hey, kid, I'm a computer. Stop all the downloading. Soldering is what does it for you. Yeah. The pipe analogy works for me. Volts is pressure, current is diameter, wattage is the amount of water coming out. Yep. Yeah, Malls. Yeah, absolutely. Pull the 97 in already so we can do some computer stuff. That's actually a good idea. I actually did make a master list in here of all the stuff that needs to be done. And you know what? Holly Terminator. I have a master list of all the stuff that needs to be done to all the cars, like all the stuff that I want to do. So like for the 59, the tack is bad in there because it's old. I need to replace it. I have a replacement. I just got to wire it up. I want the oil battery and temperature gauges in there. The heater core is not hooked up. I would like to hook it up. The transmission pan gasket is bad. It's leaking a little bit. It looks like at some point I broke a bolt off on one of the pans. So we got to helicoil that, and because those bolts aren't torqued very much. We got to tap and helicoil the thing, which is fine. And then I have to figure out a solution for the speedometer because the speedometer is 10 miles an hour off. We need to find different teeth for the speedo cable. Well, with OBS trucks, you know who to call. There you go, Sawyer. Yeah. There's a bit of history for you. Higher voltage needs better insulation, but less conductor. And you get less losses from the same wattage. The US used to use 240 standard, but there was a group that lobbied on 120 because it was dubiously safer. 3 guesses who supplied most of their funding. Edison? Would you sell the red Ford for $500K? $500K, Pop? Copper industry, miners, smelters, etc. Interesting. $500,000, Pop? I mean, yeah, I would. For that much, yeah, sure, absolutely. I like that. That's, yeah, sure. 500K, I could pay off my mortgage, buy another 59, and probably do all the things that I've done to that 59. I mean, it would suck. It would suck. That would really not be fun. But it would kill me to sell that thing. But for paying off the mortgage, yeah, I probably would. No, geek, I wouldn't buy a nice one. I'd buy another junk. I mean, not that Freb was junk when I got it. It's a pretty good truck. It's pretty solid. I would buy another 59 and fix it. I'd probably buy 3 or 4 more 59s. I mean, yeah, it's the wedding truck, though. A truck does mean a lot to me, and like 500K would probably be like the only way I would part ways with that vehicle. I don't know if Brimo would let you do that. You didn't have a lot. I mean, XJ, for paying off the mortgage, yeah, probably. Would you get into 1950 Ford to fix it up and sell it to make money? I'd like to start flipping cars on the sides, like on the side to streaming guys, because I have the facilities to do it. Yeah, but it's the wedding house, yeah. Yeah, we'll take 30% of it too. What? Yeah, Rocky, you know what, that's a good point. If there was tax with it, I would only accept a payment that would pay off my mortgage entirely and let me have enough money to like buy another one right off the bat. How many cars will Massachusetts let you flip before you need a dealer plate? I think it's like 4 or 5 title transfers, Hellfish, per year. But then again, getting a dealer, I mean, if the business really takes off, getting a dealer plate might not be the worst thing to do, because then if you have a dealer plate, you can go, and you have a dealer license, you can go to auctions. You can go to the government auctions, and you can flip cars really easily. Hey, Heavy, I'm good. You can go to Odessa. Exactly, Orion. Yeah, the dealer plate will get you into Odessa. Odessa is a former GM automotive manufacturing plant in Framingham, Mass. that has like probably about 5,000-6,000 cars on hand at any particular time. It's all government. It's all auction stuff. Yeah, Aqualex, the flip side of that is that, do I see myself flipping more than 3 or 4 cars a year? Probably not. I've been there in another lifetime. It's huge. Yeah, there you go, Ryan. It's interesting that you knew what Odessa was. Not a lot of people know that. Odessa is owned by Carvana now. I can't wait for SN25. The deluge test looked awesome, right, Heavy? The reason why I flipped this on, and we have permission to restream NSF stuff. That's no problem. I work for NSF on the side, believe it or not. Is because their Booster 9 made it to the pad. They moved it to the pad. Now, don't get me wrong. I don't think they're going to be... I don't think this is like stacking, per se, like full stacking. I think they're going to put the booster on there to test the upgraded pad. What is a mortgage? Sorry, not an adult. Erudite, the mortgage is the bank loan that you use to buy a house. So everybody says, oh, buying a house is so expensive. Buying a house is so expensive. The reality of the situation is that if you have provable sustainable income and probably about 5 to 10 grand on hand for a down payment, you can buy a house for 10, 15, I'd say 10, 15 grand, right? You could buy a house. The bank will lend you the money to buy the house as long as you can prove that you have sustainable income. So like, you just got to show them that you have a job that pays. And they'll lend you the money and then you pay it back over time. How the bank makes money is called interest, right? So you have an interest rate. Basically, so think about it like this, okay? If I buy a house for 100 grand, I wish, right? If I buy a house for 100 grand and I accept a mortgage from the bank, which is it's just a loan, right? But mortgage is a loan for a house, right? And the interest rate on the mortgage is 5%, right? Which actually isn't bad. And then I pay the mortgage back, right? Say we pay the mortgage back within a year. They lent you 100 grand to buy the house, but you end up paying the bank back 105 because it's a 5% interest. What's 5% of 100? 5. So you'd end up paying them back 105,000. Right? That's how the bank makes money. Right? So that's why I'm sure you've heard somewhere around like, oh, the interest rates suck. The interest rates suck. The interest rates are going up because of inflation, right? And it's making it harder to buy things because you're going to end up paying. Nobody wants to get screwed by the bank and end up paying the bank ridiculous amounts of money. Yeah, exactly. So you have your principal when you're paying a mortgage or you're paying back a loan, Erudite. You have your principal, which is the amount that they lent you, and then you have the interest amount, right? And the longer that loan is, the more money the bank could potentially make, right? Because sometimes interest rates aren't fixed; they're variable. Sometimes they move with federal rates, or just they can go up, they can go down. If you pay it back quicker, you're basically screwing the bank out of less money, which is funny to me. Yeah, Clayton, I got you. Yeah, you wanna get a fixed rate. Mm-hmm. Yeah, I have a fixed rate on my mortgage, and Brimo and I bought this house before they really started screwing the rates up. They had moved the rates up once when we bought this house. I think we're locked in at like 4 point something or other, 4.8 or 4.9, like maybe around, it might even be 5, I don't know. It's somewhere around there. It's not bad. That's fine. That's okay. Yeah, comparatively to like in 2018, 2019 before COVID hit, yeah, the interest rates were like 3. 4 to 5 is still okay. Yeah, Hellfish. Where are the rates now? I haven't checked. They're like at 7 or 8 or something. 2.9. Nice, Googer. 7-ish now. Ugh. Yeah, but yeah, Erudite, that's what a mortgage is. It's basically a loan from the bank so you can buy your house. It's funny because, like kids, like young adults, right? So like people that are 20, 21, 22, 23, they're like, I'm never going to buy a house because how can I afford a $500,000 house? Well, the reality of the situation is that if you pocket everything, you save up, and you live kind of meagerly for a little while, you build up 5 to 10 grand, and you prove that you have decent income, you can buy a house. Oh, absolutely. I mean, I probably would say don't do it now because the interest rates are bad. But even now, 7% isn't the worst. Like, when my parents bought a house in the 80s, when my parents bought the house that I grew up in the 80s, the interest rate was like 20% or something stupid. It was like 15, 16%. It was in the early 80s. Yeah, not a good time for the economy. You're dreaming, bro. 10K? 10K is good enough for a down payment, Dave. But then again, it does depend on where you live. If you live, like I live in Massachusetts, we had, I think we put down like 12. Yeah. That's enough. That's enough to get in. Webster was before he got in there, but yeah. What's PMI, Havix? Yeah, closing costs, etc., etc. Stay homeless, stick it to the banks. There you go. If that's how you want to live your life, private mortgage and personal mortgage insurance. I forget, dude. I don't know. I don't think so. Guys, the reason why we're talking about interest rates and stuff is because we're kind of waiting for them to lift 9. They put Booster 9 in the chopsticks, and I want to see them lift it. PMI is the monthly insurance cost for an FHA loan. We did not do FHA, if I'm remembering correctly. We did not do that. We didn't. There were reasons why we didn't do it. There were reasons pertaining to the building inspection. which is why we didn't get an FHA loan. Your house has to be the house that you have inspected basically has to be immaculate to get a good FHA loan, and it has to be completely up to code, if I'm remembering right. But see, like, it's funny because people say, like, oh, you know, I'll never afford those down payments. I'll never afford those down payments. You know, if we had, you know, courses for this in high school, you'd be able to realize that getting a house is not as bad as you might think. I mean, don't get me wrong, it's a big payment. It is something that you're going to be locked into for 30 years, but housing is tough in America. It really depends on where you live. That's the honest truth. It depends on where you live. Every state does it a little bit differently. It's just like we have 50 registry of motor vehicles. There's no federal motor vehicle registry. You have registry of motor vehicles in every state, and every state has different laws. 50 states, 50 different laws. So, like, if you're European looking at that, you're probably looking at it and going, what the frick? But if you live here, it's not too bad. You just basically move to the state that you with the laws that you like, which is kind of cool. I think that's really interesting. Really interesting way to do things. Every country in the EU has their own registry, too. Yeah, and I guess that would be the analog, right? Yeah, you guys have EU plates, and the different letters on the plate denote the country, right? With the EU plates. I mean, nobody has USA plates. It's just the state. Facts, MD is trash. Yeah, and I have not heard many good things about there, but that's why the US is so messed up. I don't think it's messed up. It's just, yeah. It's a good comparison considering size as well. Yeah, but Aqualix, what I'm getting at is that everybody has an EU plate with country of registry. We don't have USA plates. You just have the state plate. That there's a little bit of a difference, but that's a pretty good analog, yeah. Countries in the EU are like your states. Yeah. There are US government plates, Orion. Yeah, there's Fed plates, yeah, absolutely. It's not messed up, it's just different. Bingo. Yeah, Rocky, that's how I look at it, man. You know? It's just different. The fact that, Rocky, I mean, it blows my mind that the whole contiguous system works as well as it does. It's kind of ridiculous, dude. You can go to different states of the U.S. and it's like you're in different countries. It's very, very. I think that's fascinating to me. I think that's really cool. Problem getting a house is really a monthly bill. You need to have nothing come forward. In the general, mostly unachievable recommendation on how much of your income should go to housing is 28%. I mean, that's a recommendation, Aqualix, right? Like, when Brimo and I moved here a year ago, we were pretty house poor. In fact, you could make the argument that we're still pretty dang house poor. Brimo and I are both pretty damn fiscally conservative. We don't spend money. I blow money on car parts. I'm not going to lie to you. That's absolutely a thing. But, you know, most of the car parts that I spend money on, I end up writing off because I end up telling you guys about it, or I show putting it in for the stream and stuff. So, you know, that's the reason. It's kind of the reason why I do it. Recommendation doesn't mean limit. Yeah, I mean, but it's a recommendation for a reason. We spend 30% of our monthly net on our mortgage. Life is still very comfortable. I mean, Havocs, I think Bree and I are above that. Yeah, we definitely don't spend beyond our means, you know. But yeah, we wanted a house, man. But now we own property in Massachusetts. That's pretty cool. One lathe, yeah, right. To be blowing money is for trinkets. Truck parts aren't trinkets, yeah. Will you use us to pay for your hobby? How dare you? It's not a hobby, Tara. It's content. And I end up not paying as much taxes because I'm putting that money back into the economy, which is cool. Cost of living in Massachusetts is high, so yeah, it's to your credit to have a house there. Bingo. It's a job, yeah, exactly. If I worked in a mechanic shop, I'd be writing off all the parts too. How is this any different? You in the market for a lathe, EJ? How about a classic shopsmith in need of restoration? A shopsmith? I don't know what that is, Aldezert. Yeah. Coffee. I mean, Aldezert, maybe. I don't know. Oh. Hold on. I heard it. I don't know if that was the siren or what. Repost in case you didn't see it earlier. How much of a performance boost do you think they're getting? Oh, a lot. Yeah, Synerd, it sounded like industrial equipment. We're not expecting a launch, Tyrannolis? No. They're going to stack that booster. They're going to lift that 300-ton stage. That's, it's 9 meters by, what is it, 70, 80 meters? This thing is 22 stories tall and about 30 feet wide. They're going to lift it using this mechanized launch pad here, or at least we think they are. Not 100% sure. That's why we're kind of sitting here in a holding pattern. I mean, it's a freaking monster. It is a monster of a booster. It has 33 engines in there, dude. 33 engines. Each engine makes 500,000 pounds of thrust, which is just okay. Dress, yeah, she's a freaking beast, dude. Also, good to see you again, man. You're the Ford tech that I was talking to at the end of the stream the other day, right? You're the Ford guy. Quite fond of those. I ended up with one in my basement. It needs a good home. A shopsmith was a Swiss Army knife of woodworking tools. It was basically a motor that could become a lathe, table saw, radial arm saw, drill press, disc sander, and more. They were made, I think, like Grumman starting in World War I, so workers could continue working at home. My dad might want that. I'll ask him. Let me get back to you on that. Do you think part of the reason for more engines is not needing to deep throttle? Aerodad, I think Super Heavy has all of those engines because all right, well, we'll get into some rocket science here for a second. I figure we probably should because there's a rocket on the screen. So, first stage design is often denoted by whatever you're doing. What is the rocket supposed to be doing? So in the case of rockets, what types of payloads are you trying to move here? Okay, so SpaceX SpaceX has Starship. Starship is designed around what payloads they theoretically want to move into space. Elon has said that the theoretical datum that they have is 100 tons to low Earth orbit. Okay, so here's the thing. Okay, there's a lot of stuff to consider. So, do you make your second stage bigger if you want to move 100 tons into space, or do you make your first stage bigger? Well, it really depends. If you're aiming for 100 tons to LEO, to low Earth orbit, you're going to need an extremely high thrust to weight ratio on your second stage. You need high TWR on your second stage. Right? Coincidentally, you need high TWR on your first stage too, but I'll get more into that in a second. Why do you need high TWR? Well, you need a higher thrust to weight ratio because higher TWR, or a higher energy insertion, right? A higher energy insertion trajectory. Actually, it's not really a higher energy insertion trajectory. I mean, you could kind of call it that. But either way, a higher TWR favors low Earth orbit. Lower TWR would favor going further out into space. But since SpaceX is also looking for reusability, the second stage, Starship, ends up having a lot more extra mass on it. All the landing systems, the landing raptors, the wings, all that other stuff, the payload bay, etc., etc. Stuff that, all the tiles, all that stuff that needs to come back down. So you're going to need a high TWR stage, quite literally, because you're moving 100 tons, and then all the fuel involved with Starship, and then Starship itself up into space. If you're going to make a reusable stage like that, with the thermal protection systems incorporated in it, it's going to be big. It's going to be big. It's going to be heavy. It's going to be a lot of mass. All right? So, they need a lot of engines on their second stage. Right? You need to do that way, or else the first stage will go to launch this dang thing, and gravity will pull it back before it can circularize if you don't have high TWR with a low mass fraction, is what it's called. So mass fraction is basically how much fuel is on the rocket, how much rocket is on the rocket. What's the relationship between the amount of fuel it carries and the total amount of rocket? Okay? The better the mass fraction, the further you're going to go. It's pretty plain English. It's not plain English. It's pretty logical, like straightforward logic when you think about it. The logic is basically this. The more fuel you have on your rocket, the less rocket you have on your rocket, the further it's going to go. Pretty straightforward. You have a car. Say you take the seats out of a car and you replace the back seat with a gas tank. You're going to go further. You're carrying more propellant. You're carrying less seats, right? Straightforward stuff. Your range is going to be a lot further. Same idea kind of applies to spacecraft. Now, don't get me wrong. Cars are not spaceships unless you have a flying DeLorean. 1.21 gigawatts, right? But that's the general idea. So with Starship, because you got to move 100 tons, and then you want to make your second stage reusable, right? So you have a lot of stuff that you need to move up into low Earth orbit. You're going to need high TWR. That's even why now Elon is considering putting 9 engines on Starship and not 6 like what it has. So those design requirements require. Okay, so now you need to lob that Starship with all the stuff that's attached to it and 100 tons of whatever. Now you need to lob that up into space. You need to lob that on a big enough ballistic arc that it will be able to circularize before it literally falls back down. That favors higher TWR in your second stage, right? Now, okay, what the hell are you going to do to move that up into space? Well, that's why you have 72 meganewtons or like 15 million pounds of thrust coming from the bottom of this thing. Because here's the kicker. Now, with Starship itself, like the actual second stage, right? With Starship, it needs to be high TWR, but they have those vacuum engines on board to make up for the efficiency loss. Like generally with higher TWR, you lose delta V, but that definitely that depends on what propellant you're using. Certain propellants can shoot gases out the back of the rocket engine faster. Faster the gas goes out, faster the gas is accelerating out of the back of the rocket engine, literally more efficient. So that has to do with, molecular composition of propellants, etc., etc. But I'm just saying big words to sound cool, all right? So just ignore that. So the Raptor engines with using methane are a good medium between high TWR and good delta V. You get decent delta V from a methylox engine, and you get, with Raptor, because it's full flow stage combustion, you get really high TWR. So, delta V, the specific impulse, or basically exit velocity of the gases on the second stage, really has, second stages tend to favor specific impulse over TWR. But SpaceX with Starship needed to find a way to do both of those things to basically get that big honking spaceship up into space, or, well, in the future, hopefully get that big honking spaceship up into space. Now, you have all that. Now you need a first stage that's going to move that up there, right? That's why with first stages, right, here's the kicker. Generally, with second stages and how we think about delta V is that the more efficient the stage is, the further it's going to go. So the higher specific impulse, the lower the thrust to weight ratio, or TWR is for short, further it's going to go. That is pretty true. But here's the thing. For first stages, it's actually flipped. First stages with higher TWR and lower specific impulse end up having more delta V. Why? Why is that the case? A first stage with higher thrust to weight ratio will get the payload out of the atmosphere faster. if it gets the payload out of the atmosphere faster, or basically the rocket sciencey way of saying that would be it has a higher staging velocity. Basically, the first stage can, because it's got so much power behind it, at the behest of efficiency, right? Because usually when you try to make more thrust, the efficiency takes a dump, right? And vice versa, right? When you try to be more efficient, your thrust goes down. That's generally the case, right? But with these Raptor engines, the first stage and the high TWR in your first stage is actually going to get you more delta V. The reason why it's flipped with first stages is because of the dynamic medium that first stages fly through. Plain English way of saying that, first stages fly through the atmosphere. There's air in the way. You have to push against the air, right? You have to, Cohagen, you have to push against the air. You have to give the people the air. Right, anyway, sorry. Total recall. Mars, though, it's applicable, right? With first stages, the higher TWR you have, the more efficient you're going to be. You literally need less delta V. Okay? Push it. Right? So, the reason why they have 33 engines here in the first stage that makes 15 million pounds of thrust is because they need to accelerate that Starship fast enough and high enough to get it to A, not have Earth's grav well pull it back down, and B, give it the trajectory that it needs to be able to circularize before it falls back down. That's kind of the same thing, but you get the idea, right? I thought higher TWR was more minimal to gravity losses. No, it's both entropy. Like, yeah, I mean, I get into gravity losses in a second. So, like, yeah, I mean, yeah, I think that would be probably good to touch base on that too. So, it's really easy to have it compound on top of each other. If your TWR is around 1.0. Say you have a rocket and the thrust to weight ratio is 1.0. You fire the engine and it's basically just going to sit there. You fire the rocket, it'll just sit there. And as the fuel drains, the mass goes down on the vehicle, so eventually the TWR will go up. But it'll eventually just kind of sit there. If your TWR is like 1.1, the rocket will go up, but it'll go up slowly. Going up slow like that, lower TWR on first stages, is not very efficient, believe it or not. And that's because gravity is pushing on you and you're trying to push the air out of the way. Basically, you're right. You're going to have grav losses too on top of that, and the aerodynamics can exacerbate the grav loss. That's a good way to say it. That's probably better. It's probably a better way to say it than what I said, but it's still applicable, right? So with your first stage, the faster it basically overcomes that force of gravity and the faster it gets out of the atmosphere, the more efficient that first stage is going to be. Even though with first stages favoring high TWR, you're going to take an efficiency hit, lower specific impulse. Most first stages have terrible specific impulse. They're not very efficient. They basically brute force stuff up into space. But brute forcing it, the faster you can get it up there within the material science constraints of whatever you're launching into space, the faster you can get it up there, the more efficient you're going to be. That's the reason why why Super Heavy has so much freaking power behind it. Twice the amount of the Saturn V. Because you have your payload constraints for Starship are ridiculously heavy. Because you want it to get 100 tons up into low Earth orbit, you're going to need a ridiculously big second stage. And then on top of that, you're making that second stage reusable. So you need a lot of thrust with your second stage. So your second stage ends up being a lot of mass, a lot of extra. There's more rocket on your rocket than fuel on your rocket, right? Or at least the ratio between those is bad. And because of that, you're going to need a higher TWR first stage, right? And if you have a higher TWR first stage, you're going to need something with a ton of power to move that big old heavy reusable second stage up into space. And I say heavy, weight has nothing to do with it. It's mass because we're flying through the air. We're trying to overcome gravity. Mass is more applicable, right? What do you make of the Chinese winning the Methalox race? Vickers, I congratulate them, dude. That's cool. Good for them. But if I'm going to be a dick about it, right? Like, I don't want to steal their thunder. Like, that's cool that they did that. That's really cool. But honestly, them having that Methalox rocket getting into space and SpaceX having that Methalox rocket getting into space, I don't think is really a fair comparison. The reason why is because this is a little bit it's a little bit harder to make than the one that the Chinese launched. Now, don't get me wrong, it's still an impressive achievement, and it should be touted as such. But yeah, I don't think these are on the same level of technical difficulty here. Why attach SRB? Why strap-on SRBs are a popular option in the launch market? Attachable SRBs are a very quick and easy solution to get the TWR up on your first stage GOF. You're moving a heavier payload. It's you scale the rocket, so the rocket can have higher TWR and move heavier payloads into space. China may have won the first Methalox rocket to orbit prize. Let's see if they can keep up the pace. I mean, China has pretty awesome space ambitions, and I mean awesome in the literal sense of the word, like by definition. They have pretty grandiose plans, and good for them. They should do it. Please do it. If anything, you'll scare all the freaking politicians in DC into giving NASA more money. Is it bad if I'm kind of on board with that? Like, please keep doing stuff. Please keep. Yes. Like, am I my conscience is telling me that that's absurdly selfish, but also more space stuff. Yeah, exactly, O4. But yeah, anyway, there's one more thing that I wanted to add with this first stage, and this is the reason why it has so many engines and why it has so much power behind it. First of all, it really is about what you're moving into space. The first stage design is entirely built around the second stage in the payload in this case. So Super Heavy is built because they need to lob Starship at this trajectory, at this this angle, at this speed, to get it to be able to fire its engines and be able to circularize in this type of orbit with this much payload. It's entirely built around what your basically your stakeholder expectation is for the vehicle. In this case, it's Elon's expectations because he's the chief designer, right? So I think that even after considering all those stakeholder expectations, I still think Super Heavy has way more thrust than it's ever going to need. The other reason why I think that is to lower the duty cycle on the rockets. Now, the original question here was, the original question that was asked was, is there so many engines so they don't have to throttle down the engines? No. Raptor, due to its insanely high combustion chamber pressure and insanely high mass flow rate, makes it so it can be throttleable. Basically, when the engine's at full throttle, the combustion chamber is up at 350, 400 bar, I think. I don't know if they've gotten to 400 yet. When it's at like 40% throttle, it's still at like 100 bar chamber pressure or something absurd. Basically, so why is that a big deal? What does chamber pressure have to do with anything? So rocket engines generally don't throttle very well. Now, don't get me wrong, SpaceX is trying to buck that trend, right? And there are certain ways to make a rocket engine pretty damn throttleable. That doesn't mean there hasn't been throttleable rocket engines in the past. The X-15 in the late 50s had a throttleable rocket engine like an airplane, right? But if you think about engines like a solid rocket booster on the shuttle or on SLS, the shuttle engines themselves, RS-68s, they're not very throttleable. Why? Why are they not throttleable? Well, they're not very throttleable because in order for a rocket engine to keep doing rocket engine things, basically impinging in like a general convergent divergent rocket design. So basically a rocket with a combustion chamber, a throat, and then a nozzle, right? That's convergent divergent rocket design. You need to make a big enough explosion inside of your combustion chamber for it to pressurize. It has to pressurize. The explosion has to fill up the combustion chamber and then some. That way the gases get forced through the impingement, all right, or the throat of the rocket engine. Forcing the gases through that impingement, the throat, right, accelerates them to supersonic speeds. The gases going out are going faster than the speed of sound through the throat. That's important to understand, okay? And then those gases expand out through the nozzle. and they shoot out the back of the rocket. Long story short, in order to get the gases to hit supersonic, you have to fill up that combustion chamber with a big enough constant explosion in order for the rocket engine to work correctly. If you don't have sustainable combustion chamber pressure, so i.e. you go to throttle the rocket engine down, right? If you do that, you will not be able to sustain a good enough pressure inside of the combustion chamber. Now keep in mind, this is only certain rocket engines, right? A lot of rocket engines don't have throttle ability designed into them because they don't need to have throttle ability designed into them. Some of them can only throttle to a certain thing before that explosion gets unsustainable. Now, let's say you have like a shuttle engine and you try to take a space shuttle motor and you have a throttle quadrant hooked into it and you try to put it down to like 30% throttle. What's going to happen is the combustion chamber on it will be, you have a big enough explosion inside, basically down to about 60% of rated performance. So 60% of thrust. So if the shuttle motor, just made up numbers here, if you had a rocket engine that made 1,000 kilonewtons of thrust and you throttled it to 600 kilonewtons of thrust, it would be fine up until then. Once you start getting below that and you lower the combustion chamber pressure even more, you start to get cavitation inside of the combustion chamber. Basically, the explosion doesn't start to fill up inside of there. And because of that, the gases through the throat aren't being accelerated at supersonic speeds. So in rocket science, that's mass flow rate right there. That's m dot. Your m dot goes down. And if your m dot goes down and your gases decelerate through the throat at subsonic speeds, you made a really nice flamethrower. It's not going to give you that kick. And that's why accelerating to supersonic in the impingement point at the throat of the nozzle is so ridiculously important, because that's what makes it not a flamethrower, but like putting your thumb over the head of a hose versus just letting the hose go. All right? Combustion chamber pressure is if you had a garden hose and you turned it on and the water just spits out, right? It's not really going to do anything, but if you put your thumb over it, it's going to spray out, right? And that will generate a lot more movement. Right? If you can't accelerate the gases inside of the throat to supersonic, you basically took your thumb off the garden hose. Okay? Does that make sense? Now, so a lot of rocket engines can't go down. They can't deep throttle like that. Now, there are ways to overcome that. It really depends on your fuel delivery system. So, like, let's take a Merlin engine, for instance. The Merlin 1D, Falcon 9's engine. It has what's called a radial outward fuel injector, or a pintle injector. Basically, the way SpaceX delivers fuel inside of the Merlin engine, sprays it out in a cone instead of or sprays it out radially, like two sideways cones like this in the combustion chamber. And because they spray the fuel outwards, you can throttle the engine down, and because the way the fuel is delivered, it still maintains combustion chamber pressure. So Merlin engines can throttle. They can throttle very well. Throttling your rocket engine is very useful for if you're going to land a booster on a drone ship or on land. That's why Falcon 9 can do what it does. Right? That fuel delivery mechanisms inside of the rocket engine can make it so the explosion will fill it up no matter what, no matter how much fuel you're delivering. Right? Now keep in mind that still is important. It still is important to understand that even though the Merlin 1D engine delivers fuel in a way that where it can deep throttle and still sustain chamber pressure, it's still accelerating the gases to supersonic speeds in the throat of the engine. That's important to understand. Now, Raptor is basically brute forcing it. They use such a high combustion chamber pressure inside of those Raptor engines right there that even when the motor's at 50%, it is nowhere near the gases inside of the throat are nowhere near subsonic. So Raptor can actually deep throttle because it's literally a freaking fire hose of rocket engines. We're talking about a garden hose here, right? If Merlin 1D is a garden hose, Raptor engines are a frigging fire hose, right? And just like a fire hose, it's moving more water at much higher pressure, right? If the rocket engine is doing the same thing, but not with liquid, it's doing the same thing with gas. Literally, the more gas you can shoot out the back at higher speed, the more thrust you're going to make and the more efficient it's going to be, right? So, with these things here, Now, throttleable Raptors are good for landing, Starship coming back down and landing, Super Heavy coming back down and hovering if so it gets caught, right? Those are good for landing operations, but the throttle ability actually works in favor for Raptor engines here. Because when you deep throttle a Raptor engine, when the Raptor engine is not operating at 300 bar chamber pressure, you're actually not redlining the motor as much. And that's what I mean about duty cycle. So if you have a rocket engine that's designed to say you engineer your rocket engine to be able to fire at 100% thrust 10 times and then something breaks, right? And keep in mind, I'm keeping this very general. So you could fire it at 100% thrust 10 times and then you have to fix something. If you operate it at 50% thrust, now theoretically you could do 20 times. Now don't get me wrong, not every scale with rocketry is linear like that, but that's the general idea. You basically, if you have it at 100% thrust 10 times, then it breaks. Theoretically here, if you operate it at 50%, you could operate it 20 times before it breaks. That's the other reason why there's so many Raptors in here. So they don't have to push them to the limit, but if they need to, they can. And that actually brings up another point. The last point that I'm getting at here is that it's very clear from the first integrated flight test that they can lose a couple of engines and it's not that big of a deal. Because they're operating the engines at not near 100% thrust, or because they're operating the engines not at 100% and they're operating something somewhere near it almost, right? If an engine goes out, the other engines can compensate. And now don't get me wrong, you'll put more strain on those other engines, so those other engines might need to be rebuilt at some point on a smaller time scale than what originally was intended, but would you rather the spacecraft fall in the ocean? Right? I'll take a recovered booster with worn out engines and the payload in space over, rocket engines that are at the bottom of the ocean along with your multi-million-dollar payload and launch vehicle, right? So I think engine out capability and throttle ability and duty cycle on this is part of the reason why Super Heavy has so many freaking motors. I really don't think they need 15 million pounds of thrust to move that thing. I mean, it's very clear from the integrated flight test that they lost 3 or 4 Raptors right at the start and the thing was still going up with a pretty respectable thrust to weight. You know, there's not many rockets where you can lose 3 or 4 engines and still go up. Still have the TWR to overcome, right? It's very clear that the other Raptors compensated for it. And I think through that compensation, right, and the ability to basically ensure through like redundant fail-safes and duty cycles on rocket engines that it will ensure a more successful mission. Now, don't get me wrong. The flip side of that argument is that with rocket science, you don't really plan to fail. You try to maximize your odds of success. So being okay with saying like, oh, we might lose 1 to 2 engines on the way up is not really a good way to rocket science. You don't build a car with 8 wheels and say, oh, we might lose 4 or 5 wheels when we're driving down the highway. That's probably not a good way to do that, right? So with that being said, you know, I think it does have engine out capability if it needs to, but I don't think SpaceX is planning on it. I think it is much more about not wearing the engines out after every flight, because those Raptor engines, if this thing gets to operational status, the boosters are going to be put through their paces. Super Heavies will be flying pretty much on the frequency of Falcon 9, probably even more if Elon gets his way. And that's managing the duty cycle of the engines. Basically, I mean, components wear out. That's what happens. Managing that and trying to get the most amount of longevity out of those Raptor engines is probably a very important thing to do. And it's also an important thing that needs to be well understood. Doesn't wear increase exponentially as you approach limits? I mean, Aqualex, yeah, if we're talking very general, but you know it's more complicated than that. It might not. I mean, some pieces of mechanical equipment like engines require a break-in period where wearing the components into position actually makes it last longer. But who knows? I don't know. I don't have a Raptor engine in front of me, so I wouldn't be able to tell you. Duty. But first and foremost, above everything else, the main reason why they have so many engines is because they have a really freaking big upper stage. Starship is as tall as a Falcon 9 first stage and 2.5 times the width. It's by far and away the biggest upper stage ever built. Ever. It's bigger than a space shuttle external tank. It's bigger than an S-4B on the Saturn V. It is a monster of a second stage. And the design requirements to get something like that up into space requires a ton, or, well, 15 million pounds of thrust. So, first and foremost, it's built around getting the thing up into space. Secondly, you have engine out, duty cycle capabilities. That's all secondary and tertiary stuff to basically being able to, because the primary mission is to get that thing up there, right? The thought is that it's even better than doubling of a lifespan having the thrust. Yeah, it's not, like I said, Aqualux, it's probably not linear with rocket engines the way components wear, because nothing is linear with anything to do with aerodynamics and rocket science. There's almost never a linear correlation, ever. I mean, it does, there's something, I'm sure there's something out there, but... But to your earlier point, it's sort of like dualies. That's pretty much what I was referring to, Aqualux. I probably should have been a little more specific. I'm not talking about a car that has 4 wheels on either side, like an IFV or something. I'm talking like a semi-truck. The dualies, you can, yeah, exactly. A dually, you can afford to blow a tire, right? But that's not really why you have 4 tires on your rear axle. The reason is for load distribution. There's another way more important reason, but it is a redundant failsafe. That's why I used the 8-wheel analogy. Looking at next space flight on its schedule for August, you think that it will get pushed back? Klopp, I think September is probably when we'll see the next launch. There's still a lot of stuff that needs to be tested with that pad, which is why I decided to watch this today. Because I didn't think they would move a booster to the pad this early. But yeah, there's hopefully that was a good little tiny breakdown to why do you have so many freaking engines here? So I'm just gonna scroll up chat, make sure I didn't miss anything poignant. Bad info, Bobby, with the resub there, and Concrete Monkey with a 42-month resub. Thank you. I appreciate it, guys. Nerd had one in there. 41 months. That was a little while ago. And Jackie had a resub as well. Thank you, guys. I really do appreciate it. Sorry, I was a little late. That was a long explanation. Seeing them test the new deluge system with a static fire will be interesting. Cryo, I think that's why they're moving the booster. They're moving the booster so they can test the pad delusion suppression systems with different combination of engines to make sure that it doesn't ruin the freaking pad again. Which is, that makes sense. But also at the same time, say they put this booster down there and they do a 33 engine static fire, right? And it breaks the pad. Then your deluge system wasn't good enough, and that's what I mean. September, if one of these tests doesn't go to SpaceX's liking, they're gonna have to change stuff and they're gonna have to iterate on the design. When is the liftoff time? Master Manager, they're just testing this booster. At least we think they're testing this booster today. There shouldn't be a liftoff today or anytime soon. That's what I'm talking about, dude. I don't think we're going to see a liftoff for this thing for another couple of months. But when it does go off, that's going to be cool. What I think they're doing right now is lifting this booster onto the pad mount right here. See this little thing that looks like a stool? They're lifting. They should be lifting this thing onto the mount and then bolting it up, because they're testing a new system down here to make sure that when all 33 rocket engines fire, it doesn't break stuff down here. Because the first Starship launch a couple of months ago really broke a lot of things down here. Yeah, it made it off the pad just fine, but a lot of stuff down in this area here got a little messed up. Will it be on stream? I'll be streaming it, dude. I'll be here. I'm just going to restream SpaceX, but yeah, I'll be here. Yeah, see all those dents? That's a good point, Clap. See all the dents in those tanks right there? All those dents are from the rocket basically turning itself into an excavator and digging a hole underneath the pad and then shooting dirt out, and it bounced off the tanks and broke stuff. That's going to take a little bit of time to fix. Even a couple, like, 3 months after the flight, it did a lot of damage. That's a lot of damage. Yeah, that's right, Tessa. It excavated underneath the pad so hard that the rocks that it kind of kicked up and chunks of concrete actually came back up and hit the thing when it was leaving the pad, and I think that's the reason why it broke. 6 weeks times 2. With spaceflight health, yeah, Kappa, right? Yeah, with spaceflight dudes, this reminded me. With spaceflight, take how long whoever's building it thinks it's going to take and times it by pi. There's your schedule. So if somebody says, oh, it's going to take a week, guess what? It's going to take closer to a month. Oh yeah, I could get that done in a day. No. It's going to take 3 days. Probably 4. That's a good way to manage expectations. And this happens with everyone. It's not just SpaceX. Create a floating launch pad with a hole in the center so the ocean is your deluge system. That's been done. Oh yeah, that's been done before. You did not tell him how long it would really take, right? Yeah, Scotty, yep. Yep. Now, Feist, I would like to add that this does have a diverter down here. It kind of diverts the rocket exhaust down into this gap on either side. It looks like 2 quarter pipes underneath the rocket that shoots the flames out to the side into the water. Shooting a rocket engine just basically into standing water like that is not going to do very. It's not. It'll help, but it probably do more damage than anything. The reason why is because, well, the reason why they spray water underneath rockets or spray water on the pad when the rocket is leaving is because they're trying to absorb the sound. Water absorbs sound really good. That's why submarines use sonar instead of radar, right? And also, water is very conductive of heat. Rockets put out a lot of heat. Though spraying the water into the flame trench is basically a gigantic heat sink. All the heat that's coming off that rocket engine gets absorbed by the water, and the water turns into steam, right? Water's very efficient at conducting heat. It's very good at it. It likes heat. That's why most power plants are just use something to heat up water to spin a turbine. That's most power plants. And even power plants that don't heat up something, like the Hoover Dam or something, you're still using water to spin a turbine. It's really good at absorbing heat, like really good. So now you're getting into a physics problem here. Shooting a rocket at basically a flat plane of water, right? If you think about the surface area of the water that's exposed to air and exposed to the incoming heat, if you're shooting at basically into like a lake almost, like if your rocket's right above a lake or something, there's only a certain amount of surface area that can absorb the heat. To maximize the surface area of water that is touching air that's hot so it can absorb the most amount of water, you want droplets. Because think about it like this. You have a flat plane, right? of water, of standing water that you're shooting it into. The top of the water will absorb a lot of heat, but say it's 5 feet deep, or say 6 feet deep, say it's 2 meters. There's still all that water underneath it that's not being exposed to heat. So there's only going to be a certain number of flux correlative to surface area, like how much heat gets absorbed, correlative to surface area, okay? If you spray the water out, right, now instead of working in 2D, you're working in 3D. So a water droplet, say it has a radius of like 1 to 2 millimeter, right? Now you use pi r squared, you could figure out, well, not pi r squared exactly. It gets into trig, right? But essentially with a sphere, your surface area is a lot more, and then there's thousands of those water droplets. You can maximize the surface area by shooting the water out in droplets, and that also absorbs the sound. It has two benefits, right? It works twofold. So maximizing your surface area, right, by spraying the water out in droplets is going to absorb way more heat than just shooting into standing water. Even a system like sea launch will still shoot water into those flame ducts that go out to the sides, because that's really the only way you're going to do it. I mean, the rocket shooting right into a standing water is only going to absorb so much heat. And then you got to factor in that the pressure coming off of those rocket engines might push the water away, and then you got a big problem. Then you're not absorbing any heat, you know? Like why sawdust dispersed is really flammable compared to just sitting in a barrel. Bingo. You're maximizing the amount of surface area. That's why kindling lights on fire really, really fast. Yeah, absolutely. That's a really good way of looking. That's same idea. Same idea. Yep. Yeah, sphere volume is 4 divided by 3 times pi r cubed. Yeah, there you go. Yeah, that's a sphere. Think about the surface area there. Surface area is a lot more if you spray the water into a bajillion little tiny spheres. You're maximizing surface area so you can absorb the most amount of heat. Hey, Pacey, 49 months. Thank you. Today, I'm 49 months subbed old. Thank you. Yeah, but a sea launch rocket could easily be shot down by a shuttle with weapons on the dark side of the moon. That's a very good point. Now then, that yeah, you're not wrong, I guess. I think sea launch would. I mean, there's still a deluge system with sea launch, even though it's sitting out on water. That's the point that I'm getting at. EJ, I've been out of the space game for a while. What is sea launch? Sea launch doesn't exist anymore. Sea launch was a joint venture between Boeing and a Ukrainian rocket design bureau or rocket design company called Yuzhnoye, which just means south in Russian or Ukrainian, I think. Yuzhnoye made Zenit boosters for the Buran booster. But when the Cold War ended, right, when the Soviet Union collapsed, Boeing decided to go in there and say, hey, let's refit an oil rig so we can launch anywhere in the world at any time. And they took an old Japanese oil rig and converted it and basically put a Zenit launch pad on top of it. And with sea launch, there's 2 ships, actually. With sea launch, you have the commander and then you have the launch pad. So this ship is your integration hangar. This is your integration building, like where they store and put the first stage and the second stage together. And mission control is on here too. And then the launch pad is the final integration building and transporter erector integration and launch pad. The fuel is basically right there. See the fueling array? It's right on the side. Pretty cool, huh? So this thing used these 2 ships to basically be able to tow the entire launch pad floating out to tow the entire floating launch pad out to wherever you want. Think about it. With this, you're not constrained by azimuth or, coastal regions. You just tow this out in the middle of the ocean, you can launch anywhere. You could tow it out, you could tow it to the equator and launch from the equator. The idea is pretty sound considering how, our sea infrastructure is a lot more built out than our rocket launch infrastructure, let's say, right? And the cool thing is that the integration hangar inside of the Sea Launch Commander is enough to hold 2 or 3 of these things. So you could just send the Sea Launch Commander and the launch pad out there, and they could launch 3 missions over the course of a couple months out at sea. They could just stay out there. It's not really that big of a deal. Right? Greetings from Comic-Con. Hey, Ernok. So what killed Sea Launch and why they don't do it anymore is, well, the Zenit boosters are manufactured by Yuzhnoye in the Ukraine. And then the rocket engines they still make them, interestingly enough. The rocket engines are made by a company called NPO Energomash. Energomash is an ex-Soviet design bureau that makes rockets. They make propulsion systems. So the engine was from Russia, and the rocket body is from Ukraine. Yeah, we don't do Sea Launch anymore. Actually, it's not even 2022. 2014 kind of killed this thing. Yeah, when Russia invaded the Crimean Peninsula. Yeah, that's basically what killed this. Sea Launch had basically sat around since then, because the supply lines were got a little constrained, let's say, and then a Russian company called S7 Group bought Sea Launch Commander and the Sea Launch Pad, and they towed both of these things basically to Russia, and this is sitting in Russia now. And what the Russians are trying to do is, because they made the engines, they made the propulsion, what they're trying to do is basically build out the part that the Ukrainians made themselves, and a private company is trying to basically keep using this. But they moved it back in like 2019, 2020 or something like that, and it literally has not done anything since. It's been just sitting there doing nothing. The Commander and the launch pad. Yeah. So yeah, that's Omni. It's nothing new, to be honest with you. It's yeah, Sea Launch hasn't been a thing for a long time. It's a shame because it's a really good idea. It's really smart doing that. You know, you want to tow your launch pad. I mean, it's going to take a couple months to build the rocket anyway, right? So you tow the launch pad while the rocket's being built to wherever it needs to go. And then when the rocket's ready to go, you just send the Sea Launch Commander to anywhere where they're making it, right? Most countries have accessible seas that manufacture rockets, right? Like the Ukraine, for instance. There's that whole Black Sea thing, right? You just send the Sea Launch Commander to go get it, go get a bunch of them, bring them back, and then you could do 3 or 4 launches over the course of a year, right? And yeah, just keep the launch pad floating. Or, you know, like the other crazy part is, say you want it to go polar. If you want the rocket to go polar, towing it towards one of the poles and launching from there would be way more efficient, because your launch pad is mobile. It can literally move anywhere there's deep enough water, which is pretty nuts. It's a really cool capability, and it's a shame that we don't use it anymore. Well, it's a shame that it's kind of abandoned, you know. But yeah, that's the idea. The rocket that the Russians are trying to build for Sea Launch is called Soyuz 5. It's basically a Zenit booster with the... It's basically the Zenit booster. It looks exactly the same, but with Russia manufacturing the rocket body instead of the Ukraine. That's the Soyuz 5. Same engine as the Zenit RD-171 MVs, which is why I said that the rocket still, Soyuz 5, the rocket engine RD-171 MVs, they're still being made by Energomash, because I guess they're anticipating Soyuz 5 being a thing or something. But then again, I haven't kept up with the Russian space program as much as I used to since 2022. I have reasons. But yeah, that's Sea Launch on me. So don't get me wrong, you're not missing anything. What we're here for is this. That was also a picture of a DeLorean back there. Isn't China trying to launch from the sea? Yeah, they are, Tomast, but Tomast, China launching from the sea is they basically put a Scud missile tube, I guess. They put a Scud missile tube out on a barge and launched it from a barge. Yeah, it's not like that. I'm not going to say that it's not impressive, Tomas, but it's not sea launch, dude. It's not like building and integrating a rocket out at sea like what sea launch is supposed to do. They literally just towed a barge with a Scud, like a Scud missile launcher, or an IRBM land-based missile launcher tube, just basically already stacked vertical, and then hit the go button. Like, don't get me wrong, that's still impressive launching something from the ocean, but I don't think it's necessarily... Yeah, Synerd, exactly. I don't think it's necessarily comparable to... there's people walking out at the booster. I don't think it's necessarily comparable to Sea Launch. Sea Launch is literally a full 100% working launch pad where you can build, integrate, and launch at sea. The only thing that you need is first and second stages and payloads. First stage, second stage, payload fairing, and payloads coming from the customers. You can load up the Sea Launch Commander with, like, I think it's three of those things, and it could stay out at sea building and integrating rockets for months. What are we looking at? We're looking at Booster 9 right here. Booster 9, and this is the reason why I have coverage up. The NSF coverage here. NSF is a YouTube channel that I do work for, that I'm a contributor for. And on the NSF footage, they moved one of the boosters to the launch pad. And it looks like they might be prepping to move it here, but actually they're not going to move it with people that close. So we might switch over to Factorio for a little while. Or not Factorio, Satisfactory. It's reasonable to assume we will see a full 33 static fire testing the deluge system. I think that would be prudent, Dune, yeah. Mm-hmm. And somebody said, it kind of sucks that SpaceX abandoned the oil rig plans. Yeah. I don't think they've abandoned them. I think they've shelved them for the time being. Not enough time for trains? Maybe. I think they're aiming to stack at sunset for a sick drone shot. I'm pretty sure SpaceX is not building or making their entire integration plans based off of it looking cool. They could lift it now, Erudite, it would still look cool. I don't think they're doing all that for a photo op, but then again, they might. Derail. But we have to start disassembling, we have to start rebuilding the vertical main bus, Tessa. Like, don't you want to see that? Really wanted to mess with the factory today. Fun fact, if there was air between us and the sun would be as loud as a jackhammer all the time. I mean, it is a gigantic fusion power plant, Sevi. I would assume that that's probably not going to be quiet, right? Imagine someone ports Derail Valley Sim into Satisfactory. Oh, man. Modder's gonna mod, dude, maybe. Can we do a science stream about the Vegas Sphere? I don't know anything about the Vegas Sphere other than it looks really, really cool, Snickers. But yeah, maybe someday. I'll tell you what, guys. I'll keep this on in the background. Hi, chat. Hi, YouTube chat. YouTube chat seems very weird as a Twitch streamer. It's very weird to look at. I'll keep this on in the background, dudes, and we will. I really kind of was teeing up to play Satisfactory today. I really wanted to. So we can jump back into Derail tomorrow for Friday. How about we play nice and long Derail Valley stream tomorrow? I don't mind doing that. It seems to be, yeah, a lot. Satisfactory and Derail seem to be super popular right now. That and yeah, I like going back and forth between the two. It's fun. I'm just making sure there's no rocket launches tomorrow. No, there isn't. So yeah, we got unabated Derail all tomorrow. Going back and forth might slow the burnout. Yeah, Jimmy, I don't think I'd necessarily get burned out on either one of these games. I mean, yeah, maybe, yeah, I don't know. Let me rephrase that. It'd probably take a while. Even playing the game every day, it'd probably take a while. About Starfield, do you recall what features that Space Watch will have? No. Alright, dudes, I'm going to switch us over to Satisfactory. I hope you guys enjoyed watching the Starfield stuff. Maybe we'll take some time tomorrow before Derail to watch the city stuff.